All right, so I've been getting a lot of questions and a lot of confusions on this one. So I want to do some videos over this, finding angle measures using triangles. And so these are really going to train your brain to look and solve certain problems. And if nothing else, they really do help stimulate those problem-solving skills. So the goal is to use properties of lines and angles to find missing angles. That's all you're trying to do. You're trying to find the missing angle measure. And there's three things that really help me to solve these problems, okay? So the first is if I have a triangle, all three angles on the interior of the triangle are going to sum to 180. So I've got angles x, y, and z. X plus y plus z is going to equal 180. So this is just a general property of all triangles in Euclidean geometry, okay? And then right here, I've got a straight angle, and I've got two angles that are on either side of this ray. So anytime I have two angles that add up to that have a straight angle, I know that they're going to sum to 180. So this is called a linear pair. So this is a linear pair. And they are supplementary. That means they add to 180. So to formally write that out, A plus B, angle A plus angle B is equal to 180 degrees. And then from another previous video, I have that vertical angles are congruent, okay? So this angle and this angle are going to be the same measure. So anytime I have two lines crossing, just kind of extend that out. Anytime I have two lines crossing, any vertical angle that form are going to be congruent or equal in measure. So I have that these two angles are equal. That's what the tick mark means, so one tick mark. And then these two angles are equal, so two tick marks. And then you might say, oh, this is all well and good, but you look at the problem like this one, and you cry because you don't know what's going on. And I've been there. So let's try and make some sense of whatever this is. And pretty much one of the only ways to do that is to draw it out and kind of see where the triangles are. So we're trying to find this base angle here. And I hope you can see this. The mouse, I'm going to try and trail this. It took me a second to get a problem like this, but you've got this big triangle here. This big triangle. So what do I know about the angles inside of a triangle? Well, they're all going to add to 180. So I've got 36 and 39. I don't have this one. So I know that I can use all of these to find this missing angle here. So I'm going to solve this out and show you exactly how I would write this out. So I've got 39 plus 36 plus the measure of angle GHI equals 180. And if you're wondering where that GHI comes from, I'll show you. So you've got 36 degrees, which is FBG, this angle. And then you've got JDI is 39 degrees. And then you've got GHI. So that defines this angle here. So all three of these angles here are going to add to 180. So now I just want to solve for GHI. So I've got 39 plus 36. Well, 30 plus 30 is 60. 9 plus 6 is 15. So 60 plus 15 is going to be 75 degrees. plus the measure of angle GHI, and then I'm going to subtract 75 from both sides of this equation. And I get 180 minus 75 is 105. Okay, so what's nice about this? Well, it tells me that this angle here is 105. And if that's the case, then right here I've got a straight angle. So x and this angle here are going to add to 180. So I have 105, which is this angle here that we just found, plus x will equal 180. So 105 plus x degrees is going to equal 180 degrees. So what I can do now is just subtract 105 from both sides. And there's other ways you can solve this problem. I'm just picking the way that I enjoy solving. But I got x is equal to 75 degrees. And if you come back over here, let's see if that works. Woohoo. And so that's some of the tougher problems. And you'll get problems like this. This one, I got a similar problem the other day. So first thing I see is this triangle. So I know that all these angles will add to 180. So I'll do that. So I've got, and I'll kind of formally write this out. I've got the measure of angle ABC plus the measure of angle BAC and my hidden angle ACB will equal 180. So I'll show this. This is what I got. And I want to know what those angles are. So ABC is 41 degrees. So I'm going to write that out here. BAC is 102. And then ACB is hidden still. So we're going to find that here in a second. So I've got 41 plus 102, which is 143, plus the measure of angle ACB equals 180. So I want to find that measure. So I've got, this is addition. So I'm going to subtract 143 degrees from both sides. And I get 37 degrees is the measure of angle ACB. Yeah, that looks right. So if I come back over here, I know this angle up here is 37 degrees. Okay? So if this is 37 degrees, I've got two parallel lines with a transversal through them. And if I take a look here, 37 degrees is an alternate interior angle with x. So since that's true, this angle measure plus this is going to is going to equal the same measure. So since I got this is 37, it stands to reason that x is also 37 degrees. And so if that was a bit confusing, I'll show you this really quick. Whenever you have two parallel lines with a transversal through them, alternate interior angles are going to be congruent. So that means that they're on the interior of the two parallel lines and they appear on opposite sides of the transversal. So this purple one is congruent to this blue one as far as angle measure. So they have the same angle measure. And then this red angle is going to have the same degree measure as this green one. So if I come back over here, it's the exact same thing that's going on here. This angle measure is on the interior of these two parallel lines, and it's on the opposite side of the transversal that x is on. So they're alternate interior angles. So they have to be congruent. So this is 37 degrees. And so really a lot of this stuff, you just play with it and you try and find the puzzle. So here I've got vertical angles. So I've got, this is X, and this is 70 down here because these are vertical angles. So I know vertical angles are congruent. And then it says DE is parallel to FG, so these are parallel. And then I've got KL, this line, is perpendicular or intersects FG at a 90-degree angle. So that tells me that this angle measure here is 90. So if you take a look here, I've pretty much already solved this one. This is 90 here, this is 70, and this is X degrees. So you want to add up all these angles and set them equal to 180 and then solve for X. So really a lot of this stuff is playing with it. So if you have some trouble with this, let me know and email me and see if that helps. But a lot of this stuff is just playing with some of those theorems. So good luck. Hope this helps.